Good evening all. You're welcome to the tutorials with Common County the School Board. Today we'll take a look at physics. Now we'll talk about the measurement of time. In our last lectures we discussed measurement of mass and weight, and we distinguish between what? Mass and what? Weight. And in this class we conclude our unit of measurement. We're talking about what? Measurement of what? Time. There's nothing much to talk about here. Other than defining what time is, then talk about the units. They just use one or two devices for measuring time. Then talk about the units of time, the SI unit and the multiples, and even the sub multiples. So what is time? Who can define time for us? What is time? We'll be saying time. You'll be talking about time from your school. What is time? Who can define time for us? What is time? Any idea? Say it. Say that thing you know.
Time, in my own understanding, I say that time is that event that is used to distinguish or differentiate a reference to before and after. Something like when did this happen? It happened before this or after that.
Okay. You have an idea? Any other person? Any other person? Martina, how far? Talk to us now. Ibuduna, talk to us. What do you think? What is time? Time. What is time? And say it there. Guys, what is time? No, it's not true. Answer, what is time? Is time actually an event? but that what people will say yes is.
I say that is event.
Okay, I can define time. Let's define time. What is time? How can time be defined? Time is a fundamental physical quantity. Time is a fundamental physical quantities in which events an event is distinguished from the another events. Time is a fundamental physical quantity in which an event is distinguished from another events with reference to what? Before or after. With reference to what? Before or after. In a nutshell, devoid of long grammar, you can simply say that the time is an interval between events. True of us. I say that time is a fundamental physical quantity in which an event is distinguished from another event with reference to before or after. This one is long story. In a nutshell, simple understanding, you can simply say, in a layman understanding, just this one I define as just physics. In a layman understanding, you can simply say that Time is what? An interval between what? Events. Time is what? An interval between what? Events. That's what time is all about. Am I communicating? So, in a nutshell. Okay. If this will happen at this point or time, and this will happen at this time, by saying this time and that time, you are already setting interval, three of us, when the two events what occur. So just an interval between what events. Period. That is simple. But if you're asking, listen, try to talk about, put those. Of course, if you ask what is time in physics, for those that are writing as theory, don't just say time is event, time, interval between event. No. You feel it in physics. True of us, if you ask what is time, define time. Talk about the type of quantity time is, right? Talk about the unit of time. True of us, then you can now talk about the what? You can just end with device, use the measuring time. If the question says what is what? Time. Even if you say define time, still like this, let them choose the one they want to mark. It's better you write it well than to just cut yourself what? Short. Am I communicating? For those that are writing essay. Now let's continue. Now, what are the instruments used in measuring time? You know. Generally, from our day-to-day activity, we use what? Clock, right? Quartz what? Clock, right? The one you have in your house. You also use watch. Three of us. Then, but when you come there, that's one we call stop and stop clock. That one is highly sensitive. That one is used in laboratories. Am I communicating? In experiments. That one has accuracy of what? 0.1 what? Seconds. Am I communicating? It can read up to what? 0.1 what? Seconds. But the normal one you have, what is the smallest calibration there? In seconds. 1 second, right? Three of us. The normal one you have, your time is what? 1 second. But this stopwatch, stop clock has what? Stopwatch is 0.1 watt seconds. So you can take that at the reading accuracy. Am I communicating? Or precision. Remember, all the instruments we've been talking about, we'll be measuring their what? Accuracies. Hope you know. So take this in seriously. They may form questions. They may form questions for you. Now, what is the SI for time? SI for time is what? Seconds. Then you can have multiples. The multiples. You have taking seconds at the base unit. You have 60 seconds multiple. 60 seconds is what? 1 minute, right? Good. 60 minutes is what? Is what? 1 hour. Good. And 24 hours is what? A day, right? Why 300 is what? Is what? What of leap year? Leap year is what? Are you sure? 1 leap year is what? 360 what days? Are you sure? Okay. So this is what all we can, based on your syllabus, this is what they want us to talk about for time. So let's move on. We don't need to waste time. We are going to a new topic. We are done with units and measurements. We've done dimensions. That was the first thing we did. Immediately after talking about fundamental units and derived units, because of the derived units, we now went straight to what? Dimensions. So we are done with units and measurements. We are going to the next topic. Our next topic I want us to talk about is what? Position, distance, and displacement. Position, distance, and what? Displacement. position, distance, and what? Displacement. If you know about if you know about your coordinates, Cartesian, this thing, you understand this thing well, but you understand position well. Now, position, distance, and what? Displacement. You know, the way you say that I'm here, you know, if you check it well, you cannot just say I took your lecturer took this direction, went to this place. Should be able to do what? Point out the position of the what? Of your lecturer. Am I communicating? By knowing the good, not just about distance, direction, coordinates. No one. Let's continue. We'll get to understand it better. Now, when you want to determine a position, you must indicate the distance and the what? Direction. Am I communicating? You must indicate the what? The distance and what? Direction. So you determine the position of an object or a body by determining the what? Its position and what? Direction from other what? Points with reference to other point. There must be a reference point or frame of what? Reference. Either call it reference point or point or reference, or call it what? Frame of what? Reference. Let's assume I'm here now, right? I now move from here to here. You cannot talk about my position, my current position now, without referring to where I came from. Or you call it frame of reference, point of reference, or what? Origin. Am I communicating? So position of a body is simply the distance and the direction of the body from a particular what? Point of what? Reference, or a frame of what? Reference. That means the position of the what? The body. The distance, position of a body is defined as what? Simply the distance and direction of the body with respect to or a point of what? Reference. And I call it point of reference, or I call it frame of what? Reference, or the what? Origin. So you can never talk about a position of an object or a body without referring to where the body what? Started the what? The journey or whatever. You must talk about where the whole thing started from, okay? Good. Nothing just appear, boom. True of us. Even what appear came from somewhere. It's not true. It's not true. Even the spirit that appear, they came from somewhere. It's not true.
It's true.
So you cannot talk about position without reference to what? We are the origin. You call it origin or point of reference or frame of what? Okay. Now, so there's something I want to do now. Yeah, we'll do a kind of, we go back to our graph. Gift, come and clean this board for us. We'll do something now. We'll do something now. And for you to be able to determine that position, you have to find the coordinates of that point, the point where the body is. Talk about the coordinate of the what? The point. Coordinate of the what? The point. You know what this means? If this is a body, P, right? We have something like this. X1, Y1. Do you know what this means? Or simply XY. This thing means the position of the body with respect to in X what? Axis. And position and what? y what? Axis. Now, with that at the back of our mind, I want to draw something. If you have something like this, let me get some figures that will help us understand this. 4 bodies, okay? 4 bodies. Body A, you have something like this. 3, let's say 1, 2, okay? Then body B, bracket open, you have something like this. Body B, you have something like this. Let's assume we have something like this. We have something like this. We have something like this. YM2 minus 2 what? 2. Okay? Then, or let me use minus 1. Minus 1 what? 2. Then we have body C. You have something like this. Body C is 1 minus 2. Then we have body D. 4 bodies. We have body D. Something like this. Minus 1 minus 2. Look at this body now. These are 4 different what? Bodies. Now, remember I said that I told you that to use Cartesian coordinates, right? To determine the position of a what? Of a body. Now, we are talking about the displacement. We see going to what? Distance and what displacement. We want to just determine the position. Now, look at this now. If you have the body like this, P, what is inside this thing? This 1 minus 1's bracket, comma 2 inside the bracket means what? X and what? Y axis, okay? Now, you can put this thing now. You can put this in a graph form. You now understand what we mean by what? Position. Now, in this coordinates now, we have the x-axis and the what? Y-axis. You call the x-axis is called the what? The abscissa, right? X-axis is what? Is what? Then y-axis is what? It's called what? Ordinates. X-axis is called the what? Abscissa. Then y-axis is what? Ordinates. Now, with this now, we can now put this now in the plane, the Cartesian what? Plane. Look at how it will look like. The first thing is that you draw, you heard about cardinal point, right? Have you ever heard about cardinal points? Yes. We go deep into this when we enter the displacement. But I want to draw something on the board now. We have here, this is y-axis, okay? And this is what? X-axis. X-axis. You know this one, right? Your secondary school. Good. This here what? This is what we call the what? Ordinates, right? And this is what? This is what? Abscissa. And this is the what? The origin. Am I getting? Anything, this part of y from here to here is the positive what? Part of y. Am I getting? Anything below this origin is what? The negative part of what? Y. Now, anything to the right of the what? Origin is the positive part of what? Of what? X. Remember your number line, right? This is positive part of X. The anything to the left of the origin is what? Negative part of what? X. Now, we can call here 1, here what? 2, here what? 3. This is 0. Anything here is what? -1, -2, and what? -3. Then above this thing is what? Above the origin is what? 1, 2, and what? 3. Then this y below this origin in y-axis is what? -1, -2, -3. Now we can find the position of these 4 bodies here now. For body A, look up. For body A, remember that the first one is what? X, right? X is 1 for body A. Y unit, we don't know the unit. We are not interested in the unit now, okay? Just 1 unit. Y is what? 2 units. We can trace it here. Look up, look up, look up, look up. Are we together? Now this is for body A. X is what? 1. Here X is 1. Here, right? Yes. And Y is what? 2. Now we can trace X here. The point between, you can trace X here and trace what? Y here. This is the position of what? Body A. Okay? Are we listening? This is the position of what? Body A. Now for body B, X is -1 and Y is 2. For body B, X is what? -1 and Y is what? 2. We can extrapolate this to trace it. We have, they will join here, right? Yes. At this point. This is the position of what? Body what? And this position of what? Body A. Now, for body C, X is what? 1. And Y is what? -2. This is X is 1 here. For body what? C. C. And X is what? Y is what? -2. So this is the position of what? Body C. Are we together? Are we together? This is the position of what? Body C. Now for body D, X is -1 and Y is -2. Look at X here. This is -1, right? For body C. And Y is -2. You trace it again. Bring this one down. This is body D. Now with this thing now, you are represented, you have traced the position of what? These 4 bodies with respect to their frame here. Am I communicating? Where with respect to a particular what? Position. So this is what we call the coordinate of a what? Of a point. Am I communicating? Now, this is the best way to determine the position of a what? Of a body. Am I communicating? Position of a what? Body. Remember what we define as a position. Now, there's some question you may see like this. They will choose question like this. They will just want you to determine from it. You may have something like this. They want you to determine the coordinate of A. They will have it as a prompt like this. And we ask to determine the coordinate of what? A. Coordinate of A is simply what? Simply write this thing. 1 and what? 2. Simple. Depending on the units, they are now referring to. You just say unit, no particular what? Unit here. Okay? Good. I feel it. Actually. But then I can enter. Huh? Yeah. Even the vision of position I gave you, you need to put it down. You put it down. Okay, what are you define as a position here? As a position of the body? When what? Mike. Please always put down something when lecture is going on. Please, it's very important. It will help your understanding and what, and the ability to retain what you said in the class. You give joy if tomorrow you bring out your note. This we are doing here, small. Before it was going on, you have a full note. It gives joy looking at all those things. This is what you did. Yeah? Please always do that something. Okay, now at this level, the lot of things in position, but at this level we'll stop here. Let's move to what? Distance. What is distance? What is distance of a body? What is distance? The what? Distance is for position of the body cover. Are you sure? Check well.
Indicates how far an object has.
How far what happened?
An object or a body has moved.
Okay. Distance is a fundamental quantity. Is it fundamental?
Yes.
Distance is a fundamental quantity that indicates how far a body has what? Moved. Am I communicating? Am I communicating? Good. How far a body has done what? Moved. Distance is a fundamental quantity that does what? Indicate how far a body has done what? Moved. Now, distance, the SI for distance is what? Put the SI is what? Meter, right? Good, meter. The SI for distance is what? Meter. And is also is fundamental at the same time is what? Scalar what? Quantity. So distance has no what? That if you just say distance, it's just distance. It has no what? Direction. Am I communicating? Good. So let me explain what I mean by distance. If from here now, listen, I move, listen carefully. If from here now I move like this and turn back like this and move like this, watch, and turn like this to then continue moving. If you are asked the distance I've covered, all these things have been doing since, you must do what? Calculate them. True of us, when you go to where I turn a circle, you can get the circumference of that circle. True of us, you can get with what? That is what? Distance. Am I computing? Good. How far the body has done what? Moved. Huh?
Is distance a fundamental quantity or
What is fundamental quantity? Let's start from there.
those quantities that are independent of the
Okay, so what do you think about it? Is it what do you think is right? No. Is the one thing I want you to know is this: the unit of distance is what? Distance is what? Meter. Distance is a measure of length. True of us. If length is a fundamental quantity, distance is also a what? It's not fundamental. Am I communicating? It's fundamental. You know whether distance, so listen carefully. Distance, height, all these are measures of what? Length. True of us. It's fundamental. But you know, when they want to talk about it in physics, they just say length. You just use one word to talk about all these measures of length. They're just called what? Length. But when you want to go into quantities that are fundamental, distance is not derived. The distance, you cannot derive distance from, if you, okay, you were not there when we are doing dimension. Whenever we see the distance, we change it to what? We change it to what? Two of us. Good. Now, I want us to compare distance with displacement. Distance with what? Displacement. What is displacement? What is displacement? In a what? Displacement is what? Distance covered in a what? Specified what? Direction. Distance covered in a specified what? Direction. So if you are talking about displacement, you must include the what? The direction of the what? Of the body. Am I communicating? The direction of the body must be what? Included. When you are talking about what? Distance. Sorry, displacement. Distance, so displacement, so they are all measures of length, but the only difference is that in the displacement you must indicate the direction. If you don't indicate direction, you're not talking about what? Displacement. Am I communicating? You are not talking about what? Displacement. Now I want to give a simple illustration. And also, depending on the path the body has taken, displacement always give the shortest route to where the body is, the position of the body. Am I communicating? Displacement always give the shortest what? Route. See what I mean? I'll draw two things on the board now to explain this. I'll draw two things on the board. Displacement gives the shortest what? Route from a particular point to the position of the what? The body. Now look at the board. Look at the board. Look at the board. Look at these two things I drew on the board. Favor. Started from here and move to this point and change direction to this point. Favor started from here, right? But this is the final destination of favor. If you want to calculate, maybe here is 50 meter. Here is 60 what? Meter. So was started from here, move like this, and move like this, and stop here. If you want to calculate the distance of favor, simply do what? Add 50 and what? So favor's distance is what? 110 what? Meter. This is favor's distance, but this is not favor's displacement. Favor took this long journey. What is shortest route from this position to this position? This is shortest what? Route. This X here, this is what? This is what? Favors what? Displacement. But it should have a direction. Direction from where it started. So you need to find this what? Angle. Okay? And for you to do that now, you draw what is called cardinal what? Point. And you cannot point, remember. This means not south, what? East and what?
West.
West. So you draw this cardinal point at this origin. This is north, south, what? East and what? Favor started here and moved here and moved here. Favor distance is what? 50 plus 6, but that is not his displacement. This is shortest. This is. Now you need to find this x, right? You need to find this x. Then find the direction where of the favor's current what? Position. And to do that, you need to find this right angle, right? You need to find this angle. If you find this angle, if you find this angle, you are good to go. Am I communicating? Am I communicating? Talk now. How?
I don't understand what you say about displacement.
I said before that displacement is shorted. Did you write that message? So here, what is shortest route here? That means your mind left. So at the point your mind, because this thing was built up from step to step. Three of us. The guy was built up from step to step. So telling me that you don't understand what I said, that means I'll clean it and start afresh. I built it step by step. It's not true. So your mind left. That's the meaning. Please let us also always be where our body is. It's very important in learning. Had it been I just do this like this, I would say okay. But I was drawing this one after the and you are seeing me drawing it, but your mind wasn't here. So how do I start from? So I should print this in some beginning.
No, so I understand from that point to that 15 to 16.
I said that favor distance is from this 50 plus what? 60. 110 meter. That is favor's distance. But favor displacement is shortest route. And I asked a question here. From the diagram now, which one is shortest route? And you said it's from here to here. It's not what you said. This is shortest what? Route. And that gives favor's what? Displacement. Now, but you need to include the what? The what? The direction. Now, how do you now find direction? You find what's called the bearing. Am I completing?
Yeah.
You find the what? The bearing. You find the what? The bearing. And for you to find the bearing, you need to find this what? Angle here. If you find this angle here, you know, angle in straight line is what? 180 degrees. If you find this angle here, you can now find, subtract it from 180 and find from here to what? Here. Am I completing? Now, but basically, you don't need to include north again. Hope you know, because this now is favor's position is southward, east, southward, east. So basically, if you find this angle here, we are going to go. Actually, you know we have two poles, north pole and south pole. Is that northeast, northwest, southwest, southeast? So either you start from north or you start from south, depending on the position of the what? Favor. Now favor is here. Look at where favor is. You can use you can use particular theory to find x. True of us, because x square is now equal to what? 50 what? Square plus what? 60 what? Square. Which is what? 50 square is what? 2000 what? Plus what? What's the answer?
6,100.
So if you find the square root, whatever it gives you should be here. This is the how far in this shortest route. But you need to include the what? The direction. How do you know the direction? Using SOHCAHTOA, you find this angle. If you so means what? Sine is equal to what? Opposite over what? Hypotenuse. So sine, S means what? Sine. So ka toa. So ka toa. S means what? Sine. Sine theta is what? Opposite over what? Hypotenuse. Are we there? I follow you. Then ka means what? Cosine. Cos theta is what? A is adjacent over what? Make is what? Hypotenuse. Now toa, tangent. Tan theta is what? Opposite over what? O is opposite over what? So using so ka toa, this side, this is the angle we are interested in, three of us. But what angle facing the what? Right angle triangle. Which one? If you turn like this, if this angle facing here, this becomes the what? Opposite. Three of us is one opposite to this angle, right? And this is the what? Adjacent to this angle, right? And this is hypotenuse. We can simply do it this way and get theta. This is what you're looking for, this theta. Are we together? Now, if you want to find this theta now, which one is opposite? This is opposite, right? And this is what? Adjacent. So that means toa, tan theta is now equal to what? 60 meter over what? 50 what meter. What's the answer? Tan theta is what? 1 point what?
0.02.
No, 60 divided by 50. 0.0. No, I just say divide this in first. It is 1 point what? 1.2. So what do you, how do we find theta? Tan inverse of what? So theta is what? Tan inverse of what? 1.2. What? Tan 1 is what? 45. 1.2 is what?
1.2 is 505.
50, right? I will follow. I'm doing something here. Just look off. Just look off. Tan theta is now tan inverse of 1.2. Tan inverse of what? 1.2, right? Which is what? 50 point what?
194.
Just leave it at 50.19. Let me leave it at 50.2, okay? Degrees. This is the theta. This theta here is what? 50 degrees. 50.2 what? That's the theta. Now, this is South Pole. You start from here and read and stop here. Bearing. You start from South Pole and what? Read and stop here. Do you know this is the position of favor is now here. Favor lies between east and what? South and east. But what is the actual position? Favor's position is what? A combination of what we got here. X. Okay? Remember I told you what define here in S? What is square root of 6 than 1? No. 6 than 1. 78 what? Okay, S is what? 78 point what? 1 meter. This is distance. This thing now is the distance component of this displacement. Are you aware? And this is the direction. So what is favor direction now? Favor is northeast. Favor is now 50 degrees south 50.2 degrees what? East. This is the position of what? Stellar. So if you want to write the displacement of favor's displacement is now combine this thing and this angle, direction. Famous displacement is now what? 78.1 meter. South 50.2 degrees what? East. This is famous what? Displacement. This component must be there, and this component must be what? There. So famous is this position actually means 78.1 meter south is south. 50.2 degrees what? East. Because he lies between what? South and what? East. So this is famous what? Displacement. There are some you will see. It may be in root form. Jam like this person very well. Am I completing?
Why not east?
No. You can't say we have two main poles. The poles are south, north and south. You don't say it's east, south. Either you say south, east, south, west, north, east. The two poles major poles are north and what? South. You can say southeast, southwest, northeast, north what? You don't say west, south. It's wrong. Okay? So this is what I've determined stellar's displacement. I hope you know. Now, ask me, stellar. What do I always call stellar? Now, look at this place. Look at this. When you are done, let's describe this. When you are done, let's describe this snake-like movement. Okay? Belong to south. Look at where Stella. Remember, with respect to where Stella started from her journey. Stella began her journey here. So what is this? What is this position? Where does it lie? Between what and what? See where CA now. What are you talking about? See where CA now. Is it not east? Is it not south? Did you listen what I say? Cardinal point: north, south, east, and west. This is where favor lies. East now. With respect to where he started from, it lies between where? Between what?
Between south and the east.
Now, so it's not south 50.2 degrees what? East. You don't say east south, is wrong. Because east is not the main pole. Am I communicating? We have two main poles. We have south and what? North. You don't start from east or west. Start from either north. If Stella is here, let's assume Stella is here. Now, look up. If Stella is here, it becomes west, south what? West. If Stella is down here, it becomes what? North, east. If Stella is here, it becomes what? Northwest. You now find the angle that should be in between. Simple. Using your what? 3. You are good to go. Are we together? Now look at this direction. Look at this movement. Michael move like this. And take him here. Michael's distance is all these things. Calculate all these things. No the formula whatever you want to use to calculate. That is Michael's what? Distance. But Michael's displacement is simply one straight line joining this and this. Altogether, this is Michael's what? Displacement. But the distance is this. Am I communicating? The same way this is that. But because you can't place this as in this form, you just say that Michael is, of course, everything here is north south. Hope you know. Are you aware? But the way to understand the difference between what, apart from this issue of direction, distance, the major thing again, apart from direction, is that displacement give you the shortest what? Route. Why distance you calculate all the rigor you use to get to that place? Does it make sense? So displacement is a vector quantity, right?
Yeah.
Displacement is a vector quantity. Displacement is a vector quantity. It's also measured in what? SI unit is what? Meter. True of us?
Yeah.
It's also in what? Meter. So with this now, I say now let me see if I can just get a simple question I can ask us. We can now solve on displacement so they can appreciate what this now said now. Okay. If what happened? This is wrong now. This makes no sense. This is how you write displacement. This 78, you write the distance and the what? Direction. Okay, this is the distance component actually, but this is the what? Direction. So with this now, you know exactly where Stella, Stella, where favor is. Is it clear? Good, please. Let me look for a question. Let's just solve it quickly. Then and let me see something. If I can see something on the displacement, based on what I explained now, we'll solve it very quickly. Then we end it here. Let me check. You know, those that use compass, using compass now, this is what they, if you want to, you can, this can be detected using compass, okay? Compass, this is what they use, maybe if they go to a place that they don't know the direction, where they are presently. This is what compass will show you. Am I communicating? Who have seen the compass before? You have not seen it. Where? A movie. Okay. So using compass bearing, you can. Okay. Maybe I'll get a question next time. Any question? Any question? In our next topic, in our next class, we enter. In our next class, we enter scalar and vector quantities. Hello? In our next class, we do what? Scalar and what? Vector quantities. Please go through it. Go through it, okay? Go through it. In our next class, we enter scalar and what? Vector quantities in physics. That should be next week, what? Saturday, right? Scalar and vector quantities. All right, in the absence of any question, we'll end our lectures here. Maybe in subsequent listener, I'll get a review that can help us answer this question, okay? Question in this form. There are many questions like that, but it's not in this material I have here. But of course, you also know that I just formulated this one. No. Yes, if you understood what I formulated here, there's no question they'll ask you that in displacement in this form you cannot answer. Okay? All right, so I know that some question I said that some question option means they may not be like this. They may be in root form. So that means I need for you to know sine theta, what is it? Sine 30 degrees is what? Is what? Is half, right? Yes. Which one is root 2 or root 1 over 2? So all those things, you learn all those things. But maybe in mathematics we treat those things, okay? We'll go into three, right? All right. God bless you. God bless you. Please study. Study and do your review assignments. Do your review assignments. All right. See you next week. Bye bye.